Continuing with section 6.2. In the last video, I showed you how to find the volume of a solid of revolution using disk methods. So now we will look at what is washer method. What is a washer? It's like a thin metal ring, so it's hollow from the inside here, and it has just metal over here in this portion. Center is a hollow, so that's what a washer is. And so what will happen is that when we cut slices or slabs of the cross section of our solid, we will get washers. So here the situation is that if you have a region like this, sometimes, so then when we revolve it about a line, it leaves some hollow spaces. So for example, when this region is revolved about the x-axis, so we get a solid like that, but you can see there is hollow inside. So you can see the rim of the edge of this solid is like you can see a washer kind of thing there. So when you will take the slices or the cross sections, you will end up getting things like that. So which means in order to calculate the area of this piece, we will calculate the area of the bigger circle and subtract the area of the smaller circle from there. So what is the radius of the outer circle? So the radius will be this much, which means f of x, and the radius of the smaller one will be here, so g of x. So the radii are f of x and g of x. So we find the area of each. So area of the outer circle will be pi fx whole square, and the area of the inner will be pi gx whole square. So I can factor out the pi. Inside we just get the square difference of the squares, and this is actually our area that we want to integrate from a to b. And here we plug it in the formula. V is equal to integral from a to b a of x dx. So we get that. So this is the formula for the finding the volume of revolution using the shell method, using the washer method, and when we are revolving about the x-axis. So note here that when we revolve about the x-axis, we have to integrate functions which are functions of x, and then when we have to have a solid of revolution is obtained by revolving the region about the y-axis, the volume is given by v is equal to pi c to d f of y whole square minus g of y whole square. We could have used other names for example, we could have used c to d u of y whole square minus b of y whole square dy. Just for a change. So anyhow, but f of x and g of x are also okay. So this is how we will do the washer method. Okay, let's see an example. So it says find the volume of the solid obtained by rotating the region bounded by the curves y is equal to x square and x is equal to y square about. So I have three different lines. So let's see. First let's draw the region and find the point of intersection so that we know what our bounds are, because over here it doesn't say, but we kind of have an idea. So if I am going to revolve it about the y-axis, so I need the integral in terms of y. So for the first case, y is equal to x square, and then y is equal to plus minus square root of x. But so square root of x will be, if I graph it, something like this. Something like that, and then x square will be like this. So they meet here. We can see this is a point 1, but we can also we will check it from the equation. So this is our region. So first case is that we revolve around the y-axis. We got something like this. So now when we make cross sections, you see we get washers with the outer radius is this much, which means the x value of this function, which was y is equal to x square, so it is x is equal to square root of y. Because we should get everything in terms of x, y, sorry, for the first case. So x is equal to plus minus square root of y, and the other one is x is equal to y square. So this one will be x square root of y outer, and this will be inner. So our volume will be equal to pi into, okay, sorry, well, you can see that we have 0, 1, x is equal to 0, y is equal to 0, and y is equal to 1. These are our bounds. So integral from 0 to 1 square root of x whole square minus square root of y whole square, square root of y whole square, and minus y square whole square. Okay, so we get pi into y square minus y to the 5 over 5. The limits from 0 to 1, which will give me pi into 1 minus 1 over 5 minus 0. So this gives me 4 over 5 pi. That is the volume in the first case. Okay, the second one is when we have we are going to rotate it about the x-axis. Let's do this one first and then we will come back to the other one. About the x-axis, it go like this. Again we have that shape. So what is the outer radius? This one, which is square root of x. So v will be equal to, and then take bounds are again from 0 to 1, square root of x whole square minus x square whole square. Can you see we will get the same, exactly the same answer? Can you see that? Okay, I'll let you finish it because you're going to get the same answer. So now what about the other one, x is equal to negative 1? What is x is equal to negative 1? X is equal to negative 1 is a line to the left of 1 unit left of the y-axis. So our line of rotation is over here. So this thing will move because it's 1 unit away from the line of revolution. So it will be 1 unit from here, from the line of. So we'll get a piece over here, and then like that. So now the outer radius will be, now always remember we measure the radius from the line of revolution. So outer radius will be this much, which means x square plus 1. So outer radius is equal to x square plus 1. Inner radius this will be this much, so it will be square root of x plus 1. But the rest is the same. So v will be equal to pi 0 to 1 x square plus 1 whole square minus square root of x plus 1 whole square dx will be equal to pi 0 to 1. So what do we get? X to the 4th plus 2x squared plus x minus x plus 2 into root x plus 1 dx is equal to I think I got it wrong. Yeah, because we had to have that in terms of pi. So outer radius, so yes, it is x, but x is equal to, so we go from here till there. So this was square root of y. So square root of y plus 1. And the inner is again x, but it is x square plus 1, y square plus 1. So that volume will be pi integral 0 to 1 outer radius. So square root of y plus 1 whole squared minus y squared plus 1 whole squared dy. Y plus 2 times square root of y plus 1 minus, so y to the 4th plus 2y squared plus 1 and then dy. So subtract, so pi 0 to 1 integral, we have y plus 2 square root of y, which I can write as y to the 1/2 plus 1 minus y to the 4th minus 2y squared minus 1 dy. Now 1 and 1 cancel out and we can integrate the rest. Okay, I think we just need to integrate now. So pi stays outside, inside we get, so y square over 2 plus 2 into y square over y to the 3/2 divided by 3/2 minus y to the 5 over 5 minus 2 y to the 3rd over 3, and then limits from 0 to 1. Pi, plug in 1, so I get 1 over 2 plus 4 over 3, because 1 to the 3/2 is just 1, minus 1 over 5 minus 2 over 3 is equal to pi into, so this is what I am going to do, the 1 with the 3 I will combine them. So 4 over 3 minus 2 over 3 gives me 2 over 3. Then I have plus 1/2 and minus 1/5. So we can combine all three. 30 is our LCM. What do I get on the top? 30 plus, minus, sorry. Plus 1/2, so 30 plus 40 minus 12. So what does that give me? 30 plus 40, 70. 70 minus 12 over 30, which is equal to 58 over 30 pi. So I think 2 goes in there. So 2 2s are 4, 2 9s are 18, and 15 29 over 15 pi. That will be the answer. So this is how we do it with if the line is little away from it is not touching our area, our region, which we have to do. Then you have to take the distance from the line of revolution to the region